Hey guys, welcome. Today we'll be talking about states of matter. Today I brought a guest along, Aaron Wilson.
Alright, so we got three states of matter: solids, liquids, and gases. First, we got solids. Solids could be anything like a watermelon. The particles inside a solid are tightly packed and cannot move freely, making them have a definite volume, a definite shape, and are not compressible. Next, we move on to liquids, like the water inside a watermelon. The particles are also tightly packed, but can move freely. They have a definite volume, but have an indefinite shape, so they form to the shape of the container they are in, and also they are not compressible. Finally, we got gases. Their particles are loosely packed, so they can move freely around wherever they want to. This means they have an indefinite volume and shape, so they will take form in whatever container they are put in, and are the only state of matter out of all these that are compressible.
These states of matter can change form between a solid, liquid, and a gas. All of these changes are physical changes because the chemical formula stays the same, but their physical properties change. To change between states of matter, you have endothermic and exothermic changes. Melting, vaporization, and sublimation are a part of endothermic reactions because it is gaining energy or heat. The exact opposite is exothermic, which consists of freezing, condensation, and deposition. In exothermic reactions, they will lose energy or heat.
Intermolecular forces, also known as IMFs, are the forces between molecules. There are different types of IMF, including London dispersion, dipole-dipole, and hydrogen bonding. London dispersion is the weakest IMF. It is in all molecules and is influenced by the mass and size, so the bigger the molecule, the stronger the LDF. Dipole-dipole is the second strongest. It has a permanent shift in charge and is only in polar molecules. Water, or H2O, has dipole-dipole because it's polar, meaning that there are more electrons on one side of the molecule than the other, making it unbalanced. Hydrogen bonding is the strongest IMF. There has to be a bond between hydrogen with either fluorine, oxygen, or nitrogen for it to be hydrogen bonding, because fluorine, oxygen, and nitrogen are the most electronegative atoms. As you can see here, fluorine bonding with hydrogen is hydrogen bonding. The strength of IMFs decide the state of matter because of kinetic molecular theory. This means that the more energy or heat added to the matter, the faster the molecules are moving, making the bonds between the molecules weaker because they're moving past each other faster. This is why solids have stronger IMF, because the molecules are moving slower.